السلام عليكم.
هلا، وعليكم السلام ورحمة الله.
هلا أبو محمد، كيف
كيف
الحال؟
حالك؟ خلينا
والله
أحط صورة ثانية. هذه حق النهار طلعت.
عندك
كيف
واحدة حق
حالك؟
الليل وواحدة حق
عندي
النهار.
واحدة حق الليل وواحدة حق النهار. آه...
زين، خلينا في شو اسمه عشان فيتامين سي، خلينا على النهار.
ترى انتبه هنا على اليوتيوب. ها
خير إن شاء الله. دكتور عبد العزيز، كيف الحال؟
خير الحمد لله، الله يسلمك. السلام عليكم.
هلا أبو عمر. دكتور لاي، في صوت سامعني؟
يس.
أوكي. طبعا دكتور لاي، احنا هنبدأ معاك تتكلم عن السي اكس، وبعدين نرجع لك في موضوع الام اكس عشان تاخذ راحه. طيب،
ما تحب، أنا كنت أتوقع كل سي إكس له امتداد في الإم إكس بيكون يعني
والله
يعني
فكره تبغى تاخذها انك مثلا تبدا تتكلم عن السي اكس ومباشره تتكلم عن الام اكس، بس هتتعب ترى.
أتوقع ما في مشكلة يعني، لأنه أنا سويت البرزنتيشنز بحيث إن هي تكون متواصلة.
خلاص تمام. ما في مشكله. طب تبغى تاخذهم كلهم، تبدا بالانترنت اوف ثينجز وبعد الكمبيوتر نتورك، ولا تبغى تريح كمبيوتر نتورك بعدين؟
خلينا يا اي او تي والنتوركس، بعدين دكتور عبد العزيز يكون ام اكس
طيب
خالص
أوكي.
يعني.
خلاص ما في مشكله.
اذا في اقتراح ثاني ما في اي مشكله.
لا ما في مشكله، بالعكس اللي يريحكم. خلاص نبدا بيك، وبعدك دكتور طباخ، وبعدين دكتور بارودي. طب خليني اعطيكم خليني لحظه، خليني احطك كو هوست. وابو عمر كمان احطه كو هوست. ابو عمر سامعني؟
ايوه اسمعك.
دكتور ايوه تمام، حياك الله. دكتور لاي, can you go ahead and share your desktop or the PowerPoint file, please?
Okay. Sure. Can you see the slides now?
Yes. لو تروح فل هذا يسموه ايش اسمه؟ فول سكرين. تمام. خلاص هنبدا ان شاء الله في غضون دقيقتين.
تمام. دكتور أيمن بيكون معنا؟
والله إن شاء الله إحنا منتظرينهم، فهو هيجي يعني. Okay, بسم الله الرحمن الرحيم. السلام عليكم. Hello everybody, and welcome to another webinar from the Computer Engineering Department at King Fahd University of Petroleum and Minerals. Tonight the plan is to, we have 3 faculty members from the department who are going to talk about the new concentration, or what we call in Arabic masarat, the new concentration programs in the undergraduate program, computer engineering program at KFUPM. Also, they will talk about the new MX programs, اللي هي برامج الماجستير المهنية, the new master program that are offered by KFUPM. And these master programs are aligned with the CX program. So it's very important that we thought that if we have we talk about both in one session. So Dr. Lai will start and he will talk about Internet of Things and computer networks. And then we'll start after that immediately with Dr. Abdulaziz. So I'm going to ask you to please, if you have any questions, to write it down. Otherwise, you're going to forget it, or you can type it into the text, into the chat, so that we don't lose it. And then we'll have Dr. Baroudi, who's going to talk about a program that is currently running in the department. It's a new master program called Robotics and Autonomous Systems. So they're going to, in total, speak for 30 minutes, and then we're going to receive your questions in the second half of the webinar. So now I'm going to ask Dr. Lai to give us his presentation. Go ahead, Dr. Lai.
Thank you, Dr. Yahya. Welcome, everyone. So I'll be presenting the programs for the Internet of Things, both at the concentration level and the professional masters. And in the second half of my presentation, I'll be going over the concentration in computer networks, as well as the professional masters in computer networks. So as you know, IoT is an important area that's a cornerstone in today's digital transformation and in the industrial revolution, or the 4th industrial revolution. And IoT is one of the main technologies behind smart cities, smart homes, smart agriculture, smart factories, and smart grid, intelligent transportation systems, as many other applications. So this CX it tries to capitalize on such important area by providing deep knowledge as well as skills in the elements of IoT, as we will see. So the program well fits or IoT well fits the Vision 2030, a number of goals, in fact, or objectives of the vision line. The program is aligned with these objectives, mainly growing and diversifying the economy, increasing the employment, as well as enhancing government effectiveness through applications of IoT in various sectors. Now, if you look at IoT as a system, you can in fact dissect it into multiple components. So any IoT system will include some or all of these components, including embedded system that is connected to some sort of sensors and actuators. Now, to reach or to make it even more interesting, you start connecting those embedded systems together through some sort of communication and networking. And by networking, you can tap into the cloud with all its glory and services that it can provide to you. And of course, because IoT usually is connected to some real assets, like for example, factories, plants, smart grids, or even nuclear reactors, you need information security to guard your system. Now, IoT also, at its core comes the data that you need to analyze to understand your application and also to implement various applications. And this is where big data and artificial intelligence comes to play. So we try to cover as much as possible all these components in the concentration. And we culminate this with industrial applications, a course that will cover IoT in an industrial setup, focusing on technologies that are used in today's industries to make sure students also have a clear understanding of how IoT is actually being used. So the first course in the concentration is called Introduction to Smart Systems, and it covers mainly embedded systems as well as sensing and actuation. So here we are hoping students will have skills to program embedded systems and interface them to some devices like sensors and actuators, and also gain an understanding of how sensors actually work, how you convert physical measurements into digital data. The second course is called Internet of Things, and it covers the communication and networking aspects from connecting embedded systems together to even connecting them to the cloud, building cloud applications, and also covering some of the security required for IoT systems. The third course is coming from the ICS department, and it's Big Data Analytics, where students will again learn about computational models and programming, as well as the way to process, store, and analyze big data using artificial intelligence and machine learning to be able to cover as much as possible of the IoT world. And the last course will be from the System Engineering Department. It's called Industrial IoT, and that course will cover specifically protocols from the industrial IoT world, as well as showing some case studies of usage of IoT in industrial control systems, as well as smart grids and other applications of IoT. Now, who is eligible to enter the concentration? Well, we have made sure that the concentration is open to students from COE department, ICS, and software engineering programs, as well as EE and CISE students. Now, the program requires knowledge in two areas: computer networks and electronics. Now, for computer networks, normally EE students and CISE, they don't take it as a core. So if EE students are interested or CISE are interested in taking this concentration, they have to take one of those three courses for computer networks, either COE 344, ICS 343, or EE 400 to cover the needed background in networks. Now, for ICS, and software engineering, they don't normally cover electronics in their cores. So they will be required to take one of those two courses, either EE 236, which is now, this is a new course that is offered to COE students, and it covers both electronics and circuits. I think it will be offered next year for the first time. And the other option is to go with electronics, which is EE 203. So it is open to everyone, but if someone is interested to come to the program from outside the CO department, we encourage the student to make sure to take those courses before the senior year. So here is another look at the courses and their prerequisites. So the smart systems requires knowledge in electronics, and the Internet of Things required knowledge in networks, as well as the industrial Internet of Things. Now, Big Data Analytics is another course which requires knowledge in statistics, Now, what you see here, the prerequisites have just been approved today. If you look at this course, it is currently, it lists math and programming, but today it has been in fact changed. So this is going to be official soon, but I'm just sharing this. So for ISE students, CISE, they need to take ISE 205, which is the statistics. For COE, ICS, and software engineering, they take STAT 319. And for EE students, they take EE 315 before they are able to take ICS 474. So as I said, in the embedded systems, we're going to cover all the needed knowledge and skills required to program. Students will be exposed to knowledge about sensors and actuators, embedded systems, their types and their programming, and as well as aspects of power management, how you manage the power, because normally IoT systems run on batteries, and it is crucial to manage the available power. The second course will cover many networking protocols and technologies which are used today to join IoT systems or glue the devices together. So that's a look at the topics. For the industrial IoT, as I said, this will include many protocols specific to IoT, but from the industrial world, as well as case studies of how you use IoT for predictive maintenance, for other applications in the industrial world. And in big data is going to cover storing, transporting, as well as performing computations on big data using unconventional tools like machine learning and other similar techniques. So that is a quick look at the concentration. Now, the concentration shares at least half of the courses with the master program, and that's why I'm going to go to the master program, so I don't have to repeat myself. So the master program is entitled MX and IoT and embedded systems, because it covers, it gives more room to embedded systems and gives more room to also the treatment of IoT. Now, to join the program, one is the general requirements from KFUPM is you have to have a GPA 2.5 and higher on a scale of 4, and also TOEFL or IELTS with the indicated scores, and 2 recommendation letters for the program. Now, for KFUPM students, they don't have to have the TOEFL requirement. The specific requirements, on the other hand, are students have to have a bachelor in computer engineering, computer science, software engineering, electrical engineering, control and instrumentation system engineering, or related fields. They also need to have some knowledge of programming and basic mathematics and probability and statistics, which usually is part of any other engineering programs. Now, the difference between the MX and the CX is as follows. Here, we try to cover more or dig deeper into IoT by, for example, in the perception layer, which is usually the layer where you have the embedded system, we cover the introduction to smart systems, as well as another dedicated course for real-time systems, which are systems that have mission-critical timelines you need to achieve. And those applications are common in industrial and military applications. In the network, we cover IoT and industrial IoT. And in the applications where there is a dedicated course for cloud and edge computing, as well as the big data analytics course. Now, in addition to these, there is one course on IoT security. It's, of course, more elaborate course. And there is another course on embedded software engineering, where students learn how to engineer their software, the full stack, taking into considerations all the safety and proper testing of their applications. And one big difference between the CX and the MX is the MX has a project, and the project spans 2 semesters where the student is expected to implement a complete IoT system to solve an engineering problem under the supervision of an academic advisor. Now, one note here is these 4 courses cannot be taken for credit if you have taken the CX courses, the IoT and Industrial IoT, Big Data, and Introduction to Smart Systems. These have a lot of overlap with the courses in the CX program. So if someone takes the CX and then takes the master, he or she have to take the different courses to substitute these 4. If you're coming for the master only, then you can take all the courses as seen here. Now for the master, this is a look at the degree plan. So you can see Smart Systems, Internet of Things, Embedded Software Engineering, and Big Data Analytics in the first semester. In the second semester, Industrial IoT, Cloud and Edge, Real-Time Systems, and a project. And in the summer, the student is expected to finish the last course as well as finish up his project. So that is a look at IoT. I think the questions are left to the end, Dr. Yahya. So I can move to the...
Yes, please go ahead.
Okay. So let me share the other set of slides.
So I'm posting some links related to the MX program on the chat for more information about the MX program, the rules and the admission. So please visit the website. Okay, تفضل دكتور.
Okay. Now, the other program, of course, I'm presenting this on behalf of Dr. Tariq Al-Shaltami, who has worked on preparing and chairing the master, the concentration as well as the master program. Now, the concentration in computer networks capitalizes on, of course, our expertise as COE department. We have an abundance of resources, faculty, as well as courses in computer networks that is unique to our department, and therefore computer networks, we claim it's our area. The CX is open to students in COE, ICS, software engineering, both CISE and ISE, so all system engineering students as well as EE students. The prerequisite for the concentration is, again, knowledge of computer networks, which can be acquired either by taking COE 344, ICS 343, which are core to the ICS software engineering and computer engineering, or EE 400, which is an elective for EE students. Again, students who are interested to take this, they need to make sure they take the prerequisite ahead of time, so they enter the concentration. So the concentration has 4 courses. The first course is COE 444, which is the network design. And in this course, the students are going to learn how to start with the requirements of a network. For example, the size, the number of users, the applications you're using, all kinds of requirements, and then you build a network with such that matches such requirements. COE 446 covers mobile computing, and that has to do with all computing you see now that's mobile. So mobile means a laptop or a phone, or all those different technologies which are wireless and allow you to use your computer on the move are under the umbrella of mobile computing. Cloud and edge computing covers aspects of the cloud. So how the cloud is built, and what the cloud is, and how you build cloud applications, and also how to do some computations at the edge of the network, which is a very new area that's evolving as well. And the last course, ICS 445, is network management and security. and covers two things. One is network management, and that's how you monitor your network for fault and security, and also for billing and accounting and other usages, as well as security, which is key to any network. So these are the 4 courses in this program. Here is a more elaborate look at the 4 courses. You can go over them if you like. And
by the way, they can always go back to the video and pause the video and read the description,
sure.
because we are streaming live on YouTube and the video will be saved onto YouTube.
Yes, that's a good idea. Thank you. So here's a look at the other 2 courses with more details. So that is the computer networks concentration. Now, if you allow me, I'll just move to the MX program in computer networks. Now, the MX program, again, shares some courses with the CX. Now, the master program is a 1-year program like other professional masters. Let me just make sure. So students, to enter this master program, you again need to satisfy the general requirements of GPA and TOEFL requirements and recommendation letters. And in addition, you need to have a background in computer engineering, computer science, software engineering, electrical engineering, control and instrumentation system engineering, or related fields. As well as knowledge in programming and mathematics, probability and statistics as well. Now, this here has an introductory course in computer networks for students who don't have this knowledge. This is an advanced course, so it's not to be mistaken with, for example, COE 344. This is a graduate level computer networks course. The second one is mobile computing and wireless networks, which again covers wireless technologies from the cellular world as well as the indoor Wi-Fi systems. The computer network design, again, cover network design, and network security covers network security. And you can see the topics under each course. Network management is dedicated here in a separate course, and Introduction to Internet of Things is is another course. In fact, this Internet of Things is similar to the course that's taken in the IoT concentration, but the delivery of the course is different here, because in IoT, students are going to implement real IoT systems. For students in the networking program, they will be using mostly simulators or emulators to build the system. ICS 571 client server programming, and that's going to be a deep dive into how you build, to a client and a server, and with all the issues of synchronization and other issues that come up in a network, in a client server communication. And the last course, 557, covers emerging advancement in networks. So all the new and emerging advancement will be covered here. So currently there are, for example, topics similar, like, for example, software defined networks, 6G and beyond, and other technologies, ICN or information-centric networks. So all the new knowledge or topics will be covered in this course. So here is a look of the degree plan of the course. So the first is 540, and 540 is a computer networks course, followed by the Internet of Things and the other courses. And after that, you go to the mobile computing and COE 547, and last course about the emerging advancement will be in the summer. So this course also has a project, just like other MX programs, and students are expected to deliver a full project that's related to computer networks. So that's it for me. Sorry if I took a long time.
No, thank you, Dr. Lai. Okay, so next is Dr. Baroudi. So please, Dr. Baroudi, go ahead and share your screen. And while waiting for Dr. Baroudi to share his screen, I want to remind you that we're talking tonight about 2 CX programs, the Computer Networks and Internet of Things. And these 2 programs, Dr. Lai has just finished their presentation. And he also talked about the MX program in Internet of Things, Embedded System, and Computer Networks. So, in fact, we're talking about 4 MX programs. And next, Dr. Baroudi is going to talk about robotics and autonomous intelligence system. This is a program that is currently running in the department. And in fact, the first batch will graduate in this coming summer. So, تفضل Dr. Baroudi. Dr. Baroudi, you are muted.
Yeah. Okay. Can you see the slide now?
Yes.
Yes.
See the slides?
Yes.
Yeah. Okay. Thank you. So this MX program, it has also its sister CX, but the CX is it's hosted by the system department. So today I will talk only about the MX, the Master Program in Robotics and Autonomous Intelligent System. As Dr. Yahya mentioned, that we have started. The first batch, inshallah, will finish and graduated by summer, this summer, inshallah. So the nature of this MX is multidisciplinary, actually, or interdisciplinary. So it has topics from different background, like computer engineering, computer science, system, mechanical, electrical. Because of that, you will see courses from different departments. So the student will learn about robotics, artificial intelligence, autonomy, autonomous system, control system, machine learning, human-machine interaction, and other exciting field of study in order to develop the next generation of intelligent robots. So the student will start with the foundation, mathematical foundation, such that he can acquire the required knowledge and background so he can develop the in-depth theoretical knowledge along with practical experience. So we have 8 courses like all MX programs. We cover 4 domains: the perception, cognitive, action, and the mathematical foundation. And at the end, there's a final project. So these are the areas. You can see that the topics that covered are different topics. We talk about collaboration. So here we covered, in 3 courses. Actually, some courses are common and they cover different topics. So we start with this course hosted by the aerospace that discuss the foundation in robotics. So we talk about the mathematical foundation, linear algebra, basic of control theory, especially for those who are not in the area directly. For example, they lack some background. So we feed them with this background in the first course. Also, we give them another course in the advanced dynamic system. And also we give them this course, important course in robotics programming. So where we talk about the basic and principles of robotic programming and real system programming. Then we focus on one important middleware system that actually is the common language used these days, which is the ROS, the Robot Operating System. Also, the adaptation and the autonomy. So we cover it here in 2 courses in the 511, which we talk about the multi-agent robotic network, And in 5, 6, 7, where we cover the path planning and motion planning. For the intelligence and autonomous also, we cover it in this course, machine learning and artificial intelligence, ICS 520, and the SCE 578, which is the human-robot interaction. Lastly, for the perception, we develop a course which is 512, which is the sensors, actuators for robotics, along with the 578, which also cover part of the perception because it talk about the human-robot interaction. So you see now, we build the courses around these basic topics: cognitive, intelligence, perception, and the mathematical foundation, plus the networking. Because at the end, you need to build a full autonomous robotic system that composed of multi-robots. The required background, any engineering discipline will be accepted. Computer science will be accepted. Mathematics will be accepted. Software engineering, mechatronics, of course, or any equivalent degree in appropriate field or discipline. 2.5 is the GPA required as set by the KFUPM, IELTS 6.0, and 2 recommendation letters, as also Dr. Yahya and Dr. Ali mentioned before. These are the courses here. Of course, there are 4 common courses between the MX and the CX, which are the Introduction to Robotics, Path Planning, Artificial Intelligence, and the, this is the first 4, actually, all are common. So if you take the CX in robotics, you cannot take these 4 courses in the MX. You have to take what we have a list of replaceable courses that are in the same area or related areas. This is the flow chart. As you see, the first semester, the student will take the 4 courses. Actually, this is the foundation. As you see, all feed to the project. Then we have, this is the foundation course, is the prerequisite for 3 following courses, because they are all dependent on that. As you see, the discipline is not like, all topics are related to each other. So you have to develop a good and strong foundation so you can progress in the advanced topic. The project started in the 2nd semester, where you write your proposal in collaboration with your advisor, and we prefer to have an industry partner. So we'd like at the end to have a project that solves real solution to our local industry. And you finish it in the summer. So by the summer, you finish the 8th course and the project. And the plan now to have an exhibition, inshallah, in the fall for those who graduate from the first batch, inshallah. Currently, we have 19 students, 2 female and 17 male. The current projects, we have actually about 10 projects. We have 1 project on pipeline monitoring and inspection using UAVs and UGVs. UAVs is the unmanned aerial vehicle, and UGV is the unmanned ground vehicle. We have also another project on road maintenance using robots. We have another project on air detection of insects using AI with the help of Dr. Awami also. We have another project on medical delivery robot, plus other very interesting and industrial-based projects. That's it. Thank you very much.
Thank you, Dr. Athman. So next, Dr. Abdulaziz Tabbakh, who's going to talk about the new MX program on cloud computing and high-performance computing. So please start typing your question into the chat box. The Q&A session will start immediately after Dr. Tabbakh finishes his presentation. Dr. Tabbakh, please go ahead and share your slides. اوكي تفضل دكتور. You are muted, Dr. Tabbakh.
I just okay. Assalamu alaikum. Can you hear me now?
Yes, wa alaikum salam.
Okay, Assalamu alaikum. Today, inshallah, I'm going to present the Professional Master in High Performance and Cloud Computing. The program is offered by the College of Computer Science and Engineering, and it is hosted by the Computer Engineering Department. And we are joined with the Computer Science and Mathematics Department in offering this program. Let me give you an idea about what is the high performance and cloud computing. I believe most of you are familiar with high performance computing. Most of the computer platforms or computing platforms nowadays are considered like high performance computing. They have multiple processors, multiple nodes that can process the data. So in this course, in this program, we are going to focus on how can we better utilize these kind of state-of-the-art computing platforms. We're going to study how can we pick or choose what is the best platform for our application. How can we design our application in order to get the most out of the computing power of the device. And also we are going to get some, we're going to give some in-depth coverage of both modern computer architecture and programming paradigms. By the end of the program, the graduates will be able to design and develop some parallel programs on high performance platforms or cloud computing. These are the mission of the program. So we are going, the proposed program will prepare the graduates to have a practice in high performance and cloud computing, have an industrial career in high performance and cloud computing, and have a multidisciplinary contribution in to develop some solutions using the high performance parallel computing high performance computing, parallel programming in the domain of engineering, finance, data science, simulation, and others. So in the computer engineering department, we conducted a survey asking our alumni what are the jobs or what are the fields that they are working on, and as you can see that the cloud computing and the high performance computing are among the top 10 fields. Okay, so I'll just skip quickly over the objective. I'll jump to how it's related to the job market, how the high performance and cloud computing is going to help. Well, you know that nowadays the Vision 2030 is everything that is going on in the country is actually around the vision. So this program is going to be very crucial for the Vision 2030. Actually, it helps. It will play a very necessary role in driving the digital transformation. It will also can contribute in the some of the programs of the Vision 2030, like the National Transformation Program, the National Industrial Development, the Logistics Program, the Digital Transformation Initiatives, and many other programs that actually under the umbrella of Vision 2030. So let's talk about the requirement, and then I'm going to talk about the components of the program. So we have the general requirements by the university, which is the GPA and the standard exams. And also for this program, in order to get an admission, in order to succeed in this program, you have to have a 4-year bachelor degree in computer engineering, computer science, electrical engineering, software engineering, or some equivalent degrees. You need to have some knowledge in programming. You need to have some basic knowledge in computer architecture and organization, and also you need some background in linear algebra. So these are the list of the courses, and I'm not going to go over the list of the courses one by one. I'm going to give you the idea of how this program is actually designed, and then I'm going to refer to the courses. So in order to, when we designed the program, we thought about what do you need to know in order to be able to develop a program or a solution on high performance computing. So the first thing that you need to know is what is the state of the art computing system? What are the techniques? What are what are the limitations of the computing systems that we have right now? So for that reason, we offer the first course, the COE 502, the parallel processing architecture. Basically, we're going to discuss in this course, we're going to go over the state-of-the-art processor design, the state-of-the-art. We will focus on the multi-core processing machines. What are their limitations? What are their strengths, and what are their weaknesses, and what should you expect? And in order to utilize them, then we are going to we need to know how can we use them or how can we program. So that's why we are going to cover in the second course. We focused on GPU architecture and programming. So in the second course, we're going to focus on what is the GPU's architecture and programming. Actually, the GPUs represents the multi-core architecture and the parallel programming models. The GPUs, in fact, the top 500 supercomputers nowadays, they all get most of their processing powers coming from the GPUs. So that's why we're going to focus on the GPUs. And GPUs are basically a heavy multi-core computers. You can think of them like this. They have thousands of cores running at the same time. So if the same paradigm that you can apply to the GPUs, you can apply it to multi-core processing. In fact, in those courses also, we are going, the GPUs represent what we call the shared memory paradigm. There is another paradigm for parallel programming, which is called the message passing paradigm. We're going to cover it a little bit in the first course because this is not very common nowadays, but we're going to cover it, inshallah, in the 502. Then we are going to talk about, now we cover how closely or tightly related processors work together. Now let's talk about the geographically distributed computing system. So we're going to talk about the distributed computing. We are going to talk about the model of executions, the architectures of these distributed computing systems, how they can communicate, how can they synchronize, how can they design, what are their issues, how can we overcome these issues, and how these their like design limitations are going to affect our programs. We're going to take we're going to focus on cloud computing in the next course, because cloud computing is one of these distributed computing systems. In fact, we're going to, the cloud computing has also some other paradigms that we're going to cover in cloud computing. Cloud computing is actually taking over in the kingdom. We can see that there are so many initiatives in the last 6 months in the cloud computing area. So that's in regard of the hardware side. Now let's talk about the software side. So we're going to talk about also in this course, the ICS 507, we're going to talk about the design and analysis of parallel algorithms. We're going to talk about the techniques that you can use to design a parallel program, divide and conquer, for example, asynchronous algorithms. How can you analyze your program, and how can you pick the right technique, the right parallel algorithm technique that can fit your application. And in order to do this, you need to have some mathematical background in order to convert whatever problem that you have in hand, an engineering problem, a financial problem, a simulation problem. How can you model it using some mathematical model? So we're going to talk about applied linear algebra. These applied linear algebra will help us to convert a real life problem into some mathematical equations, and then how we can program write it in codes, and we can program it. And the last two courses here actually is the last course, the big data analytics, will focus on the application. It's going to give the students some flavor of what how can one of the applications of high performance computing. We're going to talk about big data analytics. We're going to try to link the algorithm or the techniques that we covered here in 507 in the parallel algorithms with the analysis of the big data. How can we apply those algorithms in big data? We are going to relate. We are going to see what are the techniques that we can use in big data analytics. Basically, this is an application of high performance computing. And the last one here, the last course is about quantum computers and architecture. And we added this course because we believe that quantum computers in the future are going to be part of it's part of the future, in fact, and it's going to solve some of the problems and that cannot be solved with traditional computers. And so having the knowledge of quantum computer will give the graduates some edge over some other graduates, because they know another paradigm, another way of processing the data that is not covered by other programs. So this is these are all the courses, and this is actually the degree plan. So in the first semester, we as you know that this is a 1-year program. So in the first semester, we're going to cover the parallel process architecture, the distributed computing, the applied linear algebra, and the design analysis of parallel architecture. In the second semester, we're going to cover the GPU programming and architecture, because it depends on the parallel processing architecture. Then we're going to talk about cloud and edge computing, which somehow related to the distributed computing. So it's kind of like an extension or an advanced, it will cover some advanced topics that are covered in the distributed computing. And then we have the big data analytics course. And in the summer, we are going to cover the quantum computing and architecture. And of course, we are going, one of the main parts of the program is to have a project where all the knowledge that you have accumulated throughout the program, you have to apply it in that project. And the project is going to be somehow industrial project with some academic. You are going to have an advisor from the academia as well as an advisor from the industry. This is a brief description of the program. And thank you all for.
Okay, thank you, Dr. Abdulaziz. So now we're going to start the Q&A session. We have with us also Dr. Ayman Al-Malih, chairman of the Computer Engineering Department, who's going to help us with some of the questions. So please raise your hand if you want to, if you have a question and you want to use the mic. Otherwise, you can go ahead and type your question into the chat. So I'm going to start with the question from the chat. Abdullah Al-Jamal, in the old COE program, what type of elective courses will be replaced for concentration courses? So I think this question is general, and I want to refer it to Dr. Ayman. And what are the courses in the old program that will replace the concentration courses?
Assalamu alaikum. For all any student who opting to concentration, whether this concentration belongs to computer engineering or offered by other departments, we have decided that basically the 4 concentration courses will be replaced by 3 COE major electives and 1 technical elective. As you know, in the old program, we have 2 technical electives and we have 4 COE electives in addition to the depth elective. So then you will be replacing the concentration courses by 3 major electives and 1 technical elective. So you'll be left with 1 technical elective and 1 major elective after taking the concentration.
Okay, thank you, Dr. Ayman. The second question from Al-Jamal, I think I'm going to ask Dr. Baroudi to answer this question since he has experience with the student in the MX program. The question says, do you recommend to take MX after taking more than 1 or 2 year experience in the job? So Dr. Baroudi, from your experience with the current MX student, do you advise the student to take the MX immediately after they graduate, or they go to the market and then like spend 1 or 2 years and then they come back to the university?
Well, in this batch, we have a mix. Like half of the batch, they are recently graduated, and some they have long time in industry, and both they are enjoying the program. I advise that they join the program directly, especially now, yes, it is designed for full-time students, but part-time are allowed. Part-time in the sense that It means he is working, not part-time in the sense that he will be, he will have less load. Maybe it's important to focus that the program is designed such that the student can finish the whole degree in 1 year. So it's assume you are full-time, fully dedicated. So 4 courses for the first semester, 3 courses for the second semester, along with the project, and 1 course with the project in the summer. I think if he started directly, it will be better because he has still, remember the basic background and basic knowledge in different fields.
Okay. Thank you, Dr. Baroudi. So we have a question from Hassan. Hassan, go ahead, unmute yourself and ask the question, please.
Okay, I have a question about if I'm planning to do a patent, would it be, or can I take like 2 courses?
I did not hear the first part of the question. If you are applying for?
Yeah, if I will be applying for a patent.
Patent?
Yeah.
Okay.
In the master degrees, can it be my project, or do I have to discuss it with the Dean department?
Dr. Ayman?
I'm not sure I understand the question. What is the relation of patent?
So he says that he has a patent, and I think what you mean, Hassan, you have a patent and you want to take advantage of the project, maybe to develop a prototype for the patent?
Yes.
So is this possible?
Yeah, I think you work out with your, these projects in the MX program are actually intended to be worked with the industry, and usually students try to find an advisor from the industry, an advisor from the university to work on practical things. So if you have a patent and basically its implementation is sufficient as a project, so the details have to be worked with your advisor to really find out whether it is.
I sent the message for the advisor like a week ago and he didn't reply, so just check.
1 second, Hassan. Dr. Baroudi, do you want to comment on this question?
I agree with Dr. Ayman. I mean, if he want to build a prototype and it's really related to the program that he's in, it's very welcome, especially if he find an industrial partner that will support. Because, like in MX, for example, for robotics, all our projects are real projects. So all they will be ended with the minimum, like MVP, a mini, or like a small prototype. Sometimes we need some support. So if your patent really related to the subject of the program, is very welcome, especially if you find industrial partner who support this one. Yes.
Okay, I will come back to you, Hassan. Dr. Lai, go ahead. Okay.
Yeah, I think maybe we can also make a comment about the projects in general in the MX programs. It is very open. I mean, if the student has an idea, he can bring it and discuss it with the instructor. We always welcome ideas from outside. So some students bring ideas from, let's say, their connections in the industry. Some may have their own idea that they can bring. So whether it's a patent or not, if you have an idea that you would like to use in the project, and if it is feasible, I don't see why not. You can always utilize the project for this.
Okay, طيب. Hassan, تفضل.
Okay. Who do I talk to, or who do I discuss it with?
But Hassan, are you already enrolled in any of the MX program, or you are planning to register?
No, I'm still studying in KFUPM baccalaureate degree for software engineer.
Okay,
and,
then I think this is we can you can talk about it later on. Okay. It should not be an issue. Just go ahead and apply, and I think it should not be an issue, inshallah. Will that be enough for you?
Inshallah.
Okay, barakallah fiik. Right. So I'm going to take another question from the chat. Sarah Kayal, she says, should I take TOEFL and IELTS? Yes. for the MX application, according to the rules, at least 6+ of IELTS score or 7+ of TOEFL score, and it is waived for KFUPM student. And I have already posted the link for more detail. We have an interesting question from Abdullah Al-Jamal again. Is the CX network better than the CCNA? Dr. Lai, what do you think? Should I, don't you think it's enough to take CCNA instead of taking the CX and computer network? Or what is the differentiating value of the CX and computer network?
I think we need to understand the difference between a master program and a certification. A certification
He's asking specifically about the CX.
Oh, the CX or the master? The CX.
No, the CX. El Masar.
Yeah, well, a certification is like the CCNA mainly is about, it's a technical, you can think of a degree that will give you mostly practical knowledge. However, in academic courses, they always go deeper into also the conceptual side. So you're going to have an exposure to both theory and applications in a CX. I don't think it is wise to compare the two. I mean, it depends on what your goal is. If your goal is just to have a certification that will make it, easier for you to go into the job market, then you can go to the CNA. But the knowledge that you will acquire there, will give you mostly hands-on experience. However, the CX is going to take you more into the theory and concepts compared to the CCNA.
Okay.
So I think it depends on the goal.
Okay.
Well, just like to add, so you specialize in networking, for example, by taking the CX. CX covers many aspects, for example, that are not covered by CCNA. And then you go over the certification. So once you take these courses, it will be very much much easier to go into CCNA and higher degrees. The CCNA is just the basic. As you know, we offer these CCNA certifications. Mr. Hakim basically provides the training. So these are just Cisco, like you learn about technology, specific technology when you take these certifications. However, like when you take the CX, you get a much wider spectrum about the fundamentals. You understand basically all the techniques and reasons for doing things certain way, rather than just learning how to configure a router and basically apply practicals.
Okay, so I'm not going to go through the questions that have been already answered in the chat. There is a question here from Mus'ab. He says, I am software engineering and I'm planning to take the CX and computer network. Should I take some courses in COE also, or it's enough to take ICS 343? I think that's courses on computer network and COE 202.
Yeah, I said basically all ICS and software engineering students don't need to take any course for joining the CX and computer networks. So their course ICS 343 is sufficient. So they can just join the CX computer networks without taking any course. However, for the Internet of Things, they need to take the electric circuits E236.
Mm-hmm. Right. We have about 5 minutes. If you don't have any question, I'm going to go through some of the questions that have been answered, but we will go into more detail because I think some of them are very important. Dr. Ayman, some people are still not clear about the MX degree and that it is terminal. At least in KFUPM, you cannot apply for PhD if you have an MX. Can you please explain this more?
Yes, as you know, the intention of the MX programs, they were designed basically as professional master programs with more emphasis on practical aspects and hands-on experience rather than with less basically on the theory, because the idea is to, the objective is to retrain basically the engineers who are in the job market. So they're not intended for going for graduate studies like completing PhD. If anybody is interested in PhD, it's better for you to go with the regular route, like you take the Master of Science, because you need to learn about how to do research and so on, which is not really the intention of the MX programs. While when you join the MS Master of Science programs, you learn how to do research. In the courses, you get like basically projects related to some research aspects. So the type of training or the type of study is different. So that's why the MX is meant for people who are in the job market and they want to basically improve their skills and knowledge about a certain area. So they come quickly in 1 year, they do it, and they basically upgrade themselves and go back to the market. So
okay.
that's.
I have a question for Dr. Tabbakh. Those who plan to work in infrastructure and data centers, you know, these days we heard the news that STC is planning to open new data centers. And I think there are also other initiatives by Aramco to open, to start new companies who will be selling, who will have like physical Google data centers here in the kingdom. So if I plan to join or to work in the data center and the infrastructure, it seems that this is cloud computing. I should take the MX program that you are offering in the computer engineering department. Can you please comment on this? Is this like correct perception or it's not correct?
The program actually is not designed for that, to prepare people to work in the infrastructure. But the courses, the distributed computing, the cloud and edge computing, those courses are going to also cover some part of the designing the infrastructure, but not how to manage, for example, the clusters or the cloud computing platform. So yes, they can benefit from that, but as I mentioned, the program is not designed specifically for preparing people to work or to build on the infrastructure of the cloud and cloud computing.
Okay. Another interesting question from the chat is the concept of substitution courses. Like if somebody takes the CX, let's say an Internet of Things, he has to substitute for some of the courses. And already Dr. Ayman mentioned that they can take these courses from other MX program. So are there any like rules specific to these courses, or it's open, it's up to the student? Dr. Ayman?
Yeah, actually, every MX program specifies a list of courses that can be substituted. So if a student comes from CX, for example, he took CX IoT and coming also to take MX IoT, then there will be a list of courses where the student will be allowed to select from this list. So we have done it like before, and usually, as I mentioned, mostly these are relevant courses from other MX. يعني مثلا, for example, somebody who is an MX IoT may take, for example, MX courses from MX in networking or MX on cybersecurity, or for example, maybe MX on data science, or maybe MX on AI, يعني relevant basically MXs.
Okay, so I'm just typing the deadlines for applying to the CX. It's 28th of May, I think, right, Dr. Ayman?
I think so.
And the deadline for applying to the MX is, I think, 6th of June. Yes, 6th of June, 2021. Okay, so we have about a minute. If you have any question, please raise your hand or type it into the chat. Okay, type. I would like to give like this opportunity now to the coordinator of the program if they have any final comment. We'll start with Dr. Luay. Any final comment?
Well, I would like to thank all the attendees for their for being here and also for the interesting questions. We are always open. If you have any questions, you can reach us by Teams or you can send emails, and wish you all the best. I would like to thank you, Dr. Yahya, for the wonderful moderation as always.
Thank you. And you are my sidekick, by the way. You help me with this also. Dr. Barudi?
Yeah, thank you very much, Dr. Yahya, and thank you very much for the attendees. Just I want to let you know that our robotic lab is well equipped with different type of robots that hopefully, inshallah, this coronavirus finish so you can visit the lab and do real experimentation. Right now, we are doing all this online or through simulation, but hopefully this coming batch will do all this in person and have
Inshallah.
experience on several robots, inshallah.
Dr. Abdul Aziz?
Thank you.
Thank you, Dr. Yahya. Thank you for the attendees. I would like also to thank Dr. Ayman and Dr. Luay, Dr. Uthman for their efforts in the CX.
Right. Dr. Ayman, I have a question for you. What are the new programs that you are planning to offer next year? It seems that you are very active in the COE department. So, ايش اللي مخبي لنا المستقبل؟
What I have in mind is the cloud computing, يعني CX, concentration on to be focused on cloud computing. And this is احنا طبعا what we did this year, we surveyed the students, and based on that we chose the directions. We also surveyed the industry. So but as we speak, there are lots of for example, just like CX has been developed very quickly on bioelectronics and sensors, where we are participating with the electrical engineering department. So it all really, we get like feedback from the industry, and based on that, we are open for whatever could serve the industry and help our graduates really to fulfill the needs and so on. But right now, as I mentioned, the cloud computing is the one that we have in mind.
Okay, thank you, Dr. Ayman. And I would like to thank the program coordinators for dedicating time to us to talk about these new programs. And I would like also to thank all the people in the audience for attending and listening to us. And please observe the deadline for the application to the CX and the MX program. This is going to be our last webinar for this academic year. But we are available. If you have any question, you can always reach to us through the email and our website. I'm going to post the link for our website now. Just 1 second. Okay, if you have any question, please reach out to us throughout the email. And thank you again, and تمسون على خير. السلام عليكم ورحمة الله.
السلام، شكرا لكم.
السلام.
يعطيكم العافية.